today's date, and the corresponding page number that goes in your notebook, and the unit that this topic is in. So we're first going to go over some terminology that we're going to be using. So the first is an algebraic expression. And an algebraic expression is one or more algebraic terms in a phrase. And remember that expressions do not have an equal sign. So when we're working with expressions, you shouldn't be using equal signs, and those are specifically used for equations and not expressions. There are some important parts of an expression that you need to be aware of because this terminology will be used throughout these lessons as well as your future in this math course and in future math courses. So if we have the expression 3m plus 6, that there are some important pieces that we have as a part of this expression. Notice that there is no equal sign, and so that makes up an expression. And we have, I think the easiest one to point out is that we have a variable. So those are letters that we use to represent an unknown. And when we have a variable next to a number, so you can see that there's no sign in between the 3 in this case and the m, then we call this 3 our coefficient. So regardless of what that number is, if it's a 3 or a 7, these values that are next to your variables are what we call coefficients. And then we have here, in this case, a positive 6 that is our constant. And so also on your note sheet, it's helpful if you define what these are. So it says a coefficient is a number that is multiplied by a variable. So we can see that here with 3 and m. A variable is a letter that is used to represent numbers in an algebraic expression. And a constant is a term in an algebraic expression that does not contain variables. So you can see that this 6 doesn't have any variables. There are other parts of an expression that we'll see, and this is really important for this unit especially, because we need to know what parts of an expression are. And so when we are saying combining like terms, we have to know what our terms are. And so every term is separated by either addition or subtraction. So in this case, 8g is a term, this positive 2h is a term, and negative 3 is a term. So when we are talking about like terms, those are terms that contain the same form of a variable. So some examples are if we have 2x and we are adding 3x to that our x's are like terms, and so that gives us 5x. So 2 plus 3 gives us 5. Similar, we have negative 8m minus 2m, so our m's are like terms. So negative 8 and negative 2 give us a negative 10m. Some things to also consider are some non-examples. So if we have 2x and a positive 3y, that these are not like terms because they are not the same form of variable. So 2x plus 3y does not become 5xy. It would actually just stay 2x plus 3y. So let's try a few examples together. So here are some steps to follow in working with combining like terms. So the first step is to simplify the expression so there is one sign between each term. Next, we are going to rewrite the expression with like terms together. And third is to combine our like terms. So a couple of things to keep in mind is when we are writing our simplified version, that we need to make sure that we write our expressions in alphabetical order. So make sure that you write a note to yourself as well. So writing in alphabetical order, and then we're going to write our constants on the right. And this is just a standard form that you'll see throughout your math courses. So make sure that when you simplify that you write in alphabetical order and your constants are on the right. So when we're looking at like terms, if we have 7y plus 8 minus 3y plus 2, so we first need to identify what our like terms are. And so we have a 7y, and we also have a negative 3y, so our variables are the same, so those are like terms. We also have a positive 8 and a positive 2. So our first step set to simplify the expression so there is one sign between each term. So we can see that we have one sign between the 7y and the 8. We have one sign between the 8 and the 3y, so the minus sign, and we have one sign between 3y and positive 2. So the first step is actually already done for us. So now we need to rewrite the expression with our like terms together. So remember that we're writing in alphabetical order. So in this case, we only have one variable, so our y's will come first, and our constants will be on the right. So we're going to group our like terms, so 7y. And be very careful with these types of situations that it's not just the 3y, it's the sign that's in front of the 3y that also comes down. So in this case, we have a minus 3y, so we'd have 7y minus 3y. And then we have a positive 8 and a positive 2. And so we can combine our like terms. So 7y minus 3y is 4y, and a positive 8 and a positive 2 is a positive 10. And we can also notice that 4y and 10 are not like terms, so we are done and we have simplified this expression. Let's look at another one. If we have u plus negative 10u plus negative 4 minus negative 1. So our first step says to simplify the expression so there is one sign between each term. So we can see that we have u plus negative 10u, and as we worked with integers, that is the same thing as u minus 10u, plus a negative 4 is the same as minus 4. And minus a negative 1, recall that when we have this minus here, can read that as the opposite of. So the opposite of negative 1 is a positive 1. And so then from there we should see that we have like terms. So we have a u and a negative 10u. So make sure we grab that sign in front of it. As well as we have a negative 4, wrong color, negative 4, and a positive 1. And so those are like terms. So we can go ahead and combine our like terms because they are already grouped together. So u minus 10u, and remember that if there isn't a coefficient in front of a variable, that's the same as a 1 there. So 1u minus 10. So 1 minus 10 is negative 9u. And negative 4 plus 1 is negative 3. So these are not like terms, so we have simplified this expression. So what I want you to do now is to pause the video and work out the remaining problems on your notes sheet. And when you have finished working out those last 4 problems, then push play on the video to reveal the answers. Here are the answers for the last 4 examples on your notes sheet. So you need to double check to make sure that you came up with the same simplified version of the expression, as well as you understand the process of how you got to those answers, and if you made any errors that you make the necessary changes. Let me know if you have any questions and you need some extra assistance.